Namaste, a hearty welcome to all my beloved friends. In this session, we shall try to discuss some of the important works of ancient Indian mathematicians. ಪ್ರಾಚೀನ ಭಾರತದ ಗಣಿತಶಾಸ್ತ್ರಜ್ಞರ ಕೊಡುಗೆಗಳನ್ನು ಇನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಶುಲ್ವ ಸೂತ್ರದಲ್ಲಿರ್ತಕ್ಕಂಥ ಒಂದು ವಿಚಾರವನ್ನು we shall try to understand in this session. Shulva Sutras, it is the oldest and known mathematics text in existence. It is the first significant composition of Indian mathematics. Way back in 800 to 500 BC, that is later Vedic period, which may go back to 2000 BC. Significant means important, having an important effect, having an important influence, ಗಮನಾರ್ಹವಾಗಿರ್ತಕ್ಕಂಥದ್ದು ಅನ್ನೋ ಒಂದು ಅರ್ಥ ಬರುತ್ತೆ. Shulva Sutras are in fact the compilation of oral wisdom. Wisdom means the quality of having experience, knowledge, good judgment, and the quality of being wise. Okay, compilations means put together by assembling previous separate items. So the previous knowledge experiences during our Vedic period have been put together, composed together in the Shulva Sutras. Okay, now Shulva Sutra. Shulva is the Sanskrit word which means a string, cord, or a rope. CORD, cord means thin flexible string or rope made by several twisted strands. Okay, these are the sutra texts, something pertaining to rituals, ಆಚರಣೆಗಳು, ರಿಲಿಜಿಯಸ್ ಆ್ಯಕ್ಷನ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತಹ ಒಂದು ಸೂತ್ರಗಳು ಇಲ್ಲಿ ಸಿಗುತ್ತೆ. ನಾಟ್ ಓನ್ಲಿ ದಟ್, ಇಟ್ ಕಂಟೈನ್ಸ್ geometry related to fire altar construction. Altar means a raised structure or a place to perform the rituals. The four major Shulva Sutras which are mathematically the most significant are those attributed to Boudhayana, Manava, Apastamba, and Katyayana. The oldest is the sutra attributed to Boudhayana, possibly compiled around 800 BC to 500 BC. Okay, so Boudhayana, Indian mathematician, was born somewhere around 800 BC. He was a Vedic Brahmin priest. He is said to be the original founder of Pythagoras theorem. Okay, it was India who first invented Pythagoras theorem, but globally the credit has been given to Greeks. A Vedic Rishi, Boudhayana, was the first who wrote a script explaining the Pythagoras theorem. He was also the one who calculated the value of pi. So here is a document giving the explanation for the Pythagoras theorem 1000 years before Pythagoras did this. Okay, so these are the sutras written by Boudhayana and others. Okay, Boudhayana has written around 21 chapters with 289 sutras, Apasamba 21 chapters with 192 sutras, Katyayana around 6 chapters with 67 sutras, and Manava 16 chapters with 228 sutras. All together, put together, it will work out to 772 sutras are there in our Shulva Sutras. So to recall some of the great Indian mathematicians who lived from 400 to 1200 ADR, very few of them I am citing here: Aryabhatta, Varahamitra, Brahmagupta, Bhaskaravan, Sridhara, Mahavira, Bhaskara too. Many others are there. I am just citing here very few Indian mathematicians who lived between 400 to 1200 AD. Now, today we will discuss the contributions made by Boudhayana, the first ever Indian mathematician who came up with several concepts in mathematics. He was one of the mathematicians who used his mathematical skills in a practical way by being a skilled craftsman. The value of pi was first calculated by him. He was a Vedic Rishi and Vedic Brahmin priest. Square root of 2, correct to 5 decimal places. This is given by Boudhayana in 800 BC, and the source is Shulva Sutra. This is given as chapter number 2. The name of the chapter is Transformation of Geometrical Figures. Okay, chapter number 2, 12th Sutra. Okay, now we know that the square root of 2 is 1.4121356237 etc. This is an irrational number, that is non-terminating and non-recurring decimal. This we know. Yes, Boudhayana gave a value for root 2 like this. It's so amazing. Let us try to see what value Boudhayana has given to us. He says root 2 is approximately equal to 1 plus 1 by 3 plus 1 over 3 into 4 minus 1 over 3 into 4 into 34. So this is the value given by Boudhayana in 800 BC for the square root of 2. Okay, so before we say anything about this, it is better to verify this expression by doing the simplification. So if you concentrate on this last term, if you multiply 3, 4 and 34, it becomes 1 over 408. Now we can take the LCM. LCM is 408, and on simplification we get 577 by 408, and on division it is approximately equal to 1.4142156827. Okay, but we know that the square root of 2 is actually 1.4135623737 etc. So this is the Boudhayana's value, correct to 1, 2, 3, 4, 5 decimal places. Compare this. So it is correct to 5 decimal places, and this is the bottom one is the square root of actual value of square root of 2, and note that the difference starts from the 6th decimal place. It should have been 3, but here we are getting 5. So we can say the Boudhayana value, that is this value, is correct to the first 5 decimal place. So accurate he was. Okay. So this is the Boudhayana's value for root 2, which is correct to the first 5 decimal places. Now let us have the geometrical view of the each and every terms for the square root of 2, which is correct to 5 decimal places by Boudhayana. So geometrical view will always help us to understand, appreciate the abstract concepts like this. Shall we do that, friends, now? Here we go. Okay. So let us first try to understand the principle of the method that we are going to demonstrate now. For this, we have to consider two squares, ABCD and PQRS of side 1 unit each. Okay. Consider another square whose area is equal to the sum of the squares ABCD and PQRS. The length of the side of the combined square is actually root 2. Do you agree with this, friends? So consider two squares of side 1 unit each and take their sum. You get another square. So the length of that combined square will be actually square root of 2. This is the principle of the method which we are going to explain now. So this we will understand with the help of a figure. Here is a square ABCD and PQRS, and we have chosen a scale as 12 centimeter is 1 unit, so that we can see the figure very clearly. So each side of the two squares are 1 unit each. So what is the area of this? 1 ones are 1, so 1 square unit in both the cases. So now we have to form another square whose area is equal to the sum of the two squares ABCD and PQRS. Okay, so then the area of the combined square will be 1 plus 1, which will be 2 square unit. Okay, 1 plus 1 is 2 square unit. So then what would be the side of each side of the combined square? Means you have to take square root of this, so which is nothing but square root of 2. Okay, so this is the main principle of the method which we are trying to explain in this video. Okay, now if we keep the two above squares adjacent to each other, we get a rectangle. Okay, but we wanted a square. So how to combine these two squares to form another big square, friends? Can you think for a while? So we have to combine these two squares. If you keep one adjacent to each other, it will become a rectangle, not a square. Then how to combine these two squares so that it will form another square? So that is the main task we have to attend now. Okay. Yes, this is the plan they are going to make. In order to add the square PQRS to square ABCD, see how beautifully they have designed this method. We have to cut the square PQRS into 3 equal parts and place them on the side of the square ABCD. So that is, this square PQRS, we have to divide this into 3 equal parts, and these 3 parts should be kept on the sides of this square ABCD, so that it will form another big square only. Shall we do that now? Here we go. Apart from this, there are other methods are there to add square, friends, that you can explore later. Okay, now, so these are the two squares. We are making the square PQRS into 3 equal parts by drawing the vertical lines like this, parallel to the vertical lines, so that each part is 1/3. So now the area of this is equal to 1/3 of the total square. So these three parts are equal, and each part is 1/3 of the total square PQRS. Okay. Now this is the very interesting slide. We will now place each of the squares of the 3 parts of the squares PQRS like this. Now please concentrate. Okay. Now let us take one first square rectangle strip like this one, and place it along the breadth like this. Wow, wonderful. So the length of this new rectangle strip is 1/3. So the total length is 1 plus 1 by 3. So we have taken one piece. So there are 2 more strips are there. So we will take this one and see where we have to place. Okay, so place it along the breadth only. Okay, so this is 1/3. So the length is 1 plus 1 by 3. Now we have left out with one more as a rectangular strip of paper. What to do with this, friends? So there is one more brilliant idea they have made. Okay, the idea is we have to divide this into 1:2 ratio. So this length is 1 and this length has to be 2/3. So divide in the ratio 1:2. Now take this small square piece and place it here like this, so that this will become a square. But this one more rectangular strip of a rectangular is left out. What to do with this? How to accommodate this and place it on this original square ABCD, so that it will form another big square? For this, another fantastic idea they have made. The idea is this. So divide this rectangular strip into 4 equal parts like this. This is the second part, this is the third part, and this is the fourth part. Now take one of the first rectangular strip and try to place it here along the breadth. Okay, there are 3 more strips are there. Now let us take this one, the second one, and place it exactly on this, above this, like this. Super. Now this is the third one. Let us take this third piece and rotate it like this and place it along the length at the top. So one more piece is left. So that also we shall rotate it and try to place it here adjacent to this. So the square PQRS is divided into 1, 2, 3, 4, 5, 6 and 7 parts have been made, and all those 7 parts are kept on this square ABCD like this. But still there is one small square is left out. Okay, so that we will try to understand now. Okay, so now you can see that the breadth here is 1, from here to here is 1 unit, and this is 1/3 and this is 1/12. So the total length is 1 plus 1/3 plus 1/12. So here also the total length is 1 plus 1/3 plus 1/12. So please observe this one also. Okay. Now this is 2/3 and the length from here to is 2/3, this is 2/3. Therefore from here to here is the total length is 2/3 plus 2/3 is 4/3. Okay, so we have placed the square PQRS on the sides of the square ABCD by dividing it into 7 pieces, 7 parts. Friends, I am very happy to inform you that all these animation have been done by one of my close friend, Shri Mohit Esra, a technocrat from Bangalore only. So I thank sincerely Mohit Esra for all the support he is giving to me in this regard. Okay. Yes. Now, so let us name them as ABCD. This is 1 unit, this is 1/3, and this is 1/12, correct? Okay, so what is this length, friends? This square which is shown in red color. So this has to be 1/12 only. So area of this square shown in red color is 1/12 into 1/12. Okay, this length is 1/12 and the breadth is also 1/12. So area is length into length, so 1/12 into 1/12 only. So see, recognize how many parts are there. So there are 7 equal parts are there which belongs to the square PQRS. Okay. Yes. Note this square which is shown in red is not a part of the square PQRS. So this square, small square whose area is 1 by 12 into 1 by 12 is not the part of the square PQRS. So it is in excess. It does not belong to the sum of the square ABCD plus sum plus the square PQRS. Okay. Now, the area of square ABCD plus the area of square PQRS plus this which contains 7 parts. To this, if we add this square, okay, I am showing you in the pointer, this area of this square is 1 by 12 into 1 by 12. With the sum of these three amounts to the area of the entire combined square, the big square, correct? Okay, now therefore we can write area of square ABCD plus area of square PQRS is equal to the area of the combined square. If you transfer this to the right hand side, it will become minus area of square 1 by 12 or into 1 by 12 only. So we need to remove the excess area of 1 by 12 into 1 by 12. So we have to subtract this area so that we get what is the sum of the square ABCD plus a square PQRS. Okay, so that the remaining area is equal to the sum of the two squares, that is square ABCD plus square PQRS, as we are interested in finding the length of the sum of the two squares only. So this is the square which is in excess. Yes. Observe that if you remove the excess area of 1 by 12 into 1 by 12, if you remove this square of 1 by 12 into 1 by 12, what will happen if you remove it like this? See, the remaining figure will no more be a square. So, the remaining portion will no longer be a square. So, we have to remove this. At the same time, it should have the square shape only. So this is the main task that we are going to attend it to now. Okay. Yes. So we should remove the excess area, that is this excess area, that is from this, in such a way that the decreased area, that is the remaining area, should be in the square shape only. And how to do this, friends? This is really a big task to us. Can you think for a while how to remove this? Yes, so they have made this wonderful idea. I am very happy to share this idea with you. The idea is this: we shall decrease very, very little along the length and the breadth equally of the combined square from any one corner, such that it amounts to the decrease of the excess area of 1 by 12 into 1 by 12 only. Say, let us choose this corner. From this corner, let us remove along this breadth and along this length some amount of rectangle, such that the total area that we have decreased is 1 by 12 into 1 by 12. So that if you remove a rectangle strip from here along the breadth and along the length, this square, the combined square, will retain the original square shape only. What a wonderful idea, friends, they have made. You could appreciate this. So we are trying to remove some area which is equal to 1 by 12 into 1 by 12, such that even after removing also, it should maintain the square shape only. So for this, you come to this, you observe the figure. So come to any one of the corner, imagine a rectangle here along throughout the breadth and the length in such a way that the area is equal to 1 by 12 into 1 by 12. You remove that, you get the square only, whose sum is equal to the sum of the two squares ABCD and PQRS. Shall we do that now? Okay. Yes. So this is the one rectangle which is shown in blue along the length and the breadth. So observe this. Okay, these are the two rectangular strips which we have to remove now. This one and this one. These are the tiny rectangles in blue which are to be removed from any one corner. You can choose, instead of this, you can choose any one other three corners also, so that even after removing these rectangles, two rectangles, okay, they will maintain the square shape only, and the sum of the areas of these two tiny rectangles is equal to 1 by 12 into 1 by 12. I think you got the idea now. Okay, we will actually calculate and remove this now. Okay, each side of the combined square, let us calculate each side of the combined square is, so 1 plus, you can, in the figure also you can see, from here to here it is 1 unit, so 1 plus 1 by 3, which is 1 by 3, look at this, so from here to here it is 1 by 3, plus one more strip we have added, 1 by 12, that is from here to here it is 1 by 12. So this is the final length. From here to here it is actually 1 plus 1 by 3 plus 1 by 12. Okay, so please try to remember, recall what Boudhayana has given the value for square root of 2. So we are trying to understand it geometrically now. Okay, so let us simplify this. What is the total length? LCM being 12. Okay, so the 12, therefore the numerator is 12 plus 4 plus 1, which is 17 by 12, friends. So the total distance length from this point to this point is 17 by 12, and the breadth is also 17 by 12 only. Okay, please remember this, 17 by 12 is the length of the combined square only. Okay, observe the figures. Okay, now in the next slide. So the length of the combined square is 17 by 12. Imagine a very tiny rectangles on the adjacent length and the breadth separately at any one corner, such that the sum of the areas is equal to 1 by 12 into 1 by 12, which is 144. 1 by 144. So by removing these rectangles, that is point number 1, we will be removing the excess area of 1 by 12 into 1 by 12, and the remaining figure will be still in the shape of a square only, which is equal to the sum of square ABCD and PQRS. We know the length of the blue rectangles to be removed is 17 by 12. So what should be the breadth of the blue rectangles is the important question now in front of us. So what is the breadth? So that we can easily calculate like this. We know that the sum of the areas of two blue rectangles should be equal to 1 by 12 into 1 by 12. Okay, now so the length is 1 by 12, area is 1 by 12 into 1 by 12. So what should be the breadth? So this is how we can calculate the breadth of the two rectangles. So the area of rectangle in blue along the length plus area of the rectangle in blue color along the breadth. And please note that both the rectangles are of the same length and are of the same breadth only. So therefore the length is 17 by 12 into breadth we don't know, we are trying to calculate, plus the another rectangle of the same area 17 by 12 into breadth of the same breadth. This should be equal to how much? If you add these two, yes, this has to be 1 by 12 into 1 by 12. So definitely if we take out breadth as the highest common factor, we get 17 by 12 in plus 17 by 12, which is equal to 1 by 12 into 1 by 12. So therefore the breadth of the blue rectangles has to be 1 by 12 into 1 by 12 divided by 17 by 12 plus 17 by 12. So therefore the breadth is 1 by 12 into 1 by 12 divided by 17 by 12 plus 17 by 12. So let us simplify. It is 1 by 144 into 34 by 12, which is equal to 1 by 144 into 12 by 34, taking reciprocal. 12 ones are 12 12s are 144, so it is equal to 1 by 12 into 1 by 34, which is, we can write it as 1 over 3 into 4 into 1 by 34, or as Boudhayana has written, so this is the breadth 1 over 3 into 4 into 34. I think you are able to recall what Boudhayana has given the value of the root 2. So this is the breadth of the rectangle now. So please observe the figure now. We will show it in the figure also. Okay, now the length has to be 17 by 12. This is the length from here to here, and the breadth is 1 over 3 into 4 into 34, which is 1 over 408, which is approximately 0.00245. That is, we are showing here, friends, please observe. Okay, this breadth we are talking. So this breadth has to be 0.00245. So please observe this in the figure. This is the breadth whose thickness is 0.0025. I wanted to remind you the average thickness of the human hair is 0.003 to 0.005 inch. So this breadth is very much less than the human hair. So we have to think of a rectangle here and another rectangle here whose breadth is this much, which is much less than the human hair, friends. Okay, so the length is this. So breadth is this, which is 1 over 408, which works out approximately 0.00245. So area of a blue rectangle is 17 by 12 into 1 over 408, which is nothing but 1 over 12 into 24. So areas of two blue rectangles is equal to 2 times this, which is 1 over 6 into 24, which is 1 over 44 only. This is what we are trying to remove. Okay, so this is equal to the area of the two blue rectangles. So area of square ABCD plus area of square PQRS is now equal to area of the combined squares minus area of the two blue rectangles. So what is the area of the combined square? It is 17 by 12 into 17 by 12 minus 1 over 144, which is 289 by 144 minus 1 over 144. On simplification is 288 by 144, which is exactly 2 times it will cancel. So the area of the combined squares is exactly 2 square unit. So if you take square root for this, you will get approximately the value of root 2 correct to 5 decimal places. So therefore this is the square value of square root of 2. So square ABCD plus square PQRS is equal to 2, taking square root on either sides. So the length of the combined square is actually root 2. Okay, so the length is, see how much is the length and how much is the breadth. So from blue lines only we have to consider it is 1 plus 1 over 3, that is this is 1 over 3 plus 1 over 12. From this we have to subtract, 1 over 3 into 4 into 34. That is the rectangle whose breadth is this much. If you remove this, then we are going to get the area of the rectangle, the square whose sum is equal to area of the two squares. So therefore, Boudhayana said root 2 is approximately 1 plus 1 by 3 plus 1 over 3 into 4 minus 1 over 3 into 34 only. So a great tribute to Boudhayana and other ancient Indian mathematicians. So I would like to stand up and give a big round of applause for the great mathematicians. Thank you very much. Yes, to continue. So, some of the bibliography which I have referred is Shulva Sutras by S.N. Sen and A.K. Bhag, published by Indian National Science Academy, New Delhi, 1983, and Open Mind, Let Us Share Our Thoughts by L.V. Nagarajan, and this is the site address also. So let us rediscover many contributions made by our great Indian mathematicians about 3000 years ago and pass it on to our young generations of our state and of our country and at large to the world, and inform them with pride that how ancient Indian mathematicians have thought about the subtle things and concepts and of our rich heritage. Okay, so it is the fundamental duty and the responsibility of all the mathematics teachers to work in this regard. This is the only way we can show our respect to them and make our country prosper. Thanks for watching the video, friends. Namaste. Take care. Bye-bye. See you then.